Okay, so now we're going to use conversion factors to solve problems, and I'm going to blow through this. The video is going to be kind of short, but I'm hoping that you'll pause the video while I'm doing it, and you'll work out the problems in advance and then compare your answer to mine. So here's how this goes. Let's just dive into it. We know that we're going to be dealing with body fat a lot, so a claim that we're often told is that exercising regularly helps reduce body fat. I believe it. And so we're going to deal with body fat in several different scenarios here in this chapter as a sort of context for problems, which is great. So our learning goal is using conversion factors to change from one unit to another, and that's it. All right. Now, the process of problem solving in chemistry often requires one or more conversion factors to change a given unit to a different one, right? And so our core chemistry skill is going to be using conversion factors. Now, problem solving in chemistry requires, number one, identifying of the units that you're given. And then it also requires the units that you need, right? Where are we trying to go? And then finally, the identification of the conversion factors are going to make a connection between those two. All right? So let's do an example here. I'm going to use the picket fence method. This is not my favorite method, but I think mostly, I think students appreciate it more than students generally appreciate it. So a rattlesnake is 2.4 meters long. So there's my given unit right there, meters, okay? So I'm given meters. I'm going to set up a picket fence, and I'm going to be asked, okay, this is what I need. I need centimeters, right? Well, we know from previous conversations that 100 centimeters, kind of ugly there, 100 centimeters is equal to 1 meter. So I can use a conversion factor here, which puts meters down here and centimeters up top, and it would be 100 to 1, right? Now, since these are both within the metric system, this is an exact number and this is an exact number, but the 2.44, that's a measurement. That's what I was given in the beginning, right? So this is going to have 3 sig figs, so my answer is going to have 3 sig figs. All right, so I can see in order to get this, I'm just going to have to multiply 2.44 times 100, and I'm going to get 244. And that's it, right? Meters crossed off. I'm left with centimeters, and that's it, 244 centimeters. Okay, now sometimes we're going to need more than one conversion factor, right? And it's not always going to be obvious which ones we need. I talked to a student today who said she was having a little difficulty sort of having the inspiration to know what conversion factors to use. So hopefully this will become natural to you as you go along. Here's an example of one that requires more than one conversion factor. And just watch how I do this, okay? A doctor's order prescribed a dosage of 0.15 milligrams of Synthroid. Okay, so it's going to be, I'm given milligrams. We'll use the picket fence method, okay? I'm guessing that we won't need 3, but let's make 3 anyways, just in case, okay? So that's what I was given. I was given milligrams. If a tablet contains that many micrograms of Synthroid, that's 1 tablet. How many tablets are required? So it looks like it's going to be, I'm looking for tablets because that's what I'm asked, right? And I know I've got a conversion of tablets to micrograms, mcg, right? You know that sometimes people write that as a mu, right? That looks like an M, but it's really a Greek letter mu. It's the same thing. These two are the same thing, okay? So I know that, but what I don't know is I can't cancel out milligrams and micrograms. Aha! But I can cancel out micrograms and grams, and I can cancel out grams and milligrams, right? Those work out very nicely, okay? So this looks like it's going to work out nicely, right? Because I wanted tablets. I didn't want micrograms, I didn't want grams, and I didn't want milligrams. In my answer, I wanted tablets, right? So let's go through here and put the numbers in and see how this works out. Looks like I was given 1.50 milligrams, right? And I know that there's 1,000 milligrams in a gram. And I know that there are 1 million micrograms in a gram. Okay, all right. And it looks like there are 75 micrograms in every 1 tablet. Let's go through and do the sig figs real quickly. There are 3 sig figs here. These are within metric, so those are both definitions. Here's more definitions, so they're exact. And this is 2, and that's 1, but that's an exact because I don't have 1 tablet, right? So that's exact. So it looks like I've got 3, 2. It's going to have 2 sig figs, okay? So I'm just going to go through and do this. Actually, I'm going to make things a little simple for myself. This is a million. A million divided by 1,000 is just 1,000, right? So I'm going to get rid of that. If you want to put the 10 to the 6 over 1,000 in your calculator, that's fine. But it's going to be easier for me, I think, if I do it like that. So this looks to be 150, right? Because that times 1,000 is 150 divided by 75. Wow, look at that. This is 2. Okay? It's 2 tablets. Now, we're allowed to report 2 sig figs here, but I don't think it makes any sense to say 2.0 tablets, right? 2.0 tablets, I guess to be consistent, let's write it like that. Okay? All right, so we used more than 1 conversion factor there in order to get our answer. All right, so it looks we're going to do another more than 1 conversion factor again. All right, we were given days, and we were asked for minutes. Pause the video and set up a solution, and then compare yours to mine. How many minutes? I'm going to suppose that you did that. Okay. Minutes. Now, I don't know how many minutes are in a day, but I know how many minutes are in an hour, right? And I know how many hours are in a day, and I've got 1.4 days. 1.4 days, there are 24 hours in a day. This is exact. This is exact. There are 60 minutes in an hour. That's exact. That's exact, right? 1.4 times 24 times 60. This is going to be a big number, right? How many minutes are in a day? It's a big, ought to be a big number. I need my calculator for this one. I can't do this one in my head. So this is going to be 1.4 times 24 times 60 is equal to 2016. Is that right? Let's suppose it's right. 2016. Now this had 2 sig figs in it. 2 sig figs, and everything else was definition. So I can only say this to 2 sig figs. Oh, you're not going to like this. I'm going to have to write this as 2.016 times 10 to the 3 minutes. And I have to, this is actually equal. That was a mistake here. It's equal to that, but I have to write it as only 2 sig figs, 2,000 minutes. Okay? But I have to write it like that if I'm going to say 2 sig figs. All right, I think I've just got one more question here to do. Again, pause the video and then come back and compare your answer to mine. Okay, so it looks like I've got, here's a sort of in question equality. 65 meters is equal to 1 minute, right? How many minutes will it take you to walk a distance of 77.5 kilometers, okay? So I'm given kilometers. I don't know how many conversions I'm going to need, but I'm asking for minutes. That's what I'm being asked for. Oops, I don't want that. I'll use the picket fence method. And I see that 1 minute can be related to meters, right? And meters can be related to kilometers, okay? So there are 1,000 meters in 1 kilometer. There are 65 meters in 1 minute, according to this treadmill, right? And there are 7.5 kilometers. Kilometers cross off, meters cross off, and I'm left with minutes, which is what I wanted. So I'm going to put in my calculator 7.5, whoops, 7.5 times 1,000 divided by 65 is equal to 115.38. 3846, right, and so on. Minutes. And I got to go back through and figure out how many sig figs I got. Okay, so there's 2 sig figs here. This is a definition, so it's exact. That's a definition, so it's exact. This is not a definition. That's a measurement. There's 2 sig figs here. And this is exact. Okay? So it looks like I'm going to be writing this as 1.1538 times 10 to the 2, right? And I can only write 2 sig figs, so I'm going to have to round. That's my last one. I'm going to round this to 1.2 times 10 to the 2 minutes. All right, and there we go. All right, hope that's helpful. Good bit of practice on using problem solving using unit conversion.